Hello everyone and welcome back to MacTech 40, and today we will see one question of Indian Forest Service exam, IFS exam. Okay, we will see the question of mains exam and the subject is mechanical engineering paper 1, sorry paper 2, and this question is based on Brayton cycle. So what the question is, let's see. So I have write down the data here. So the data is, in a gas turbine plant, air enter at T1 pressure. So this is the initial pressure and temperature is T1. Initial temperature is T1. It is compressed to R times P1. That means the final pressure is R times P1. That is R is the pressure ratio. Here R is the pressure ratio. And then heated to temperature T3. That means there is a reheating, and reheating is done at the temperature T3. Sorry, not reheating, it is just a combustion chamber. It is heated to temperature T3. Sorry, my mistake. And the air is then expanded into a two-stage turbine in such that the pressure ratio is equal. That means if this is the pressure initial and this is the final pressure, so intermediate pressure is exactly divide the ratio between these two. The initial upon final pressure will be same in both high pressure and low pressure turbine. Okay, the air is reheated between the turbine stages, that means, and that again reheated to temperature T3. assume this Assume that the working fluid is a perfect gas. Okay, so that means the CPCV value, specific heat value, will be constant. It will not vary with the temperature. Okay, and the compression and expansion both are isentropic. That means there is no internal irreversibility. Then we have to prove that for the maximum work output, so the net work output will be per kg of the working fluid will be maximum. That means for maximum work output, the pressure ratio should be like this. Okay, that is T3 by T1 raised to 2 by 3 times gamma minus 1 upon gamma. So whatever in the data that is given, I have drawn here a TS diagram. Okay, this is initial condition 1, pressure P1 and temperature T1. It is compressed and then heated to temperature T3, and here corresponding pressure P3. Okay, and it is expanded up to 0.4 in high pressure turbine, and then again reheated to this point, and this point is 5, and the temperature of the 5 and 3 is same. T3 is equal to T5. I have written here. Okay, because why I've taken is the fifth point, because in numerical we will be confused that whether this 3 point or of high pressure turbine or low pressure turbine. Okay, so I have for simplicity I have taken the 5 point, but T3 and T5 is same, and there again it is expanded to 0.6 and again returned back. So, and this is the initial pressure. So whatever this intermediate pressure, I have taken the name PI, intermediate pressure. Okay, so from the given data I can write that P3 by P4, here this P3 by P4, the ratio between this P3 by P4, I'm writing over here P3 by P4 is equal to P5 by P6. Why? Because the pressure ratio is equal in both the turbine. In the data it is given, so I am taking as a P3. P3 is what? Uh, Here I can take P3. So this is P3 is what? P3 is P2. This P3 having the same pressure line, that is R into P1. Why? Because the heat addition in combustion chamber in the Brayton cycle is a constant pressure heat addition. So it is the same as the final pressure, and the final pressure is R times P1. And P4 is the intermediate pressure, so I am writing as a PI. Okay, and correct this P5 is also on the intermediate pressure, so I can write PI Look at the figure. This is P4 and P5. These both are on the same pressure line on Pi, intermediate pressure. So Pi divided by here P1, that is because P6 at the inlet pressure line. So when you solve this, you will get Pi, intermediate pressure, is equal to P1 under root R. Okay, so mark this in yellow box, so because this will help in our final result. Now the network, because we have to find this, the network output should be minimum. So what is the network then? That is the work done by compressor. So the net work done is what? Work of high pressure turbine and work of low pressure turbine minus. Why minus? Because in compression work we have to give the work, so the work is added to the system, so it is taken as a negative as per the first law of sign convention. So in high pressure turbine, Cp into T3 minus T4 plus Cp T5 minus T6 work done equation for the Brayton cycle, the low pressure and high pressure turbine I have written. And why I am not taken the mass mcp? Because per unit kg is given, so nothing worry about of the mass. So here again Cp T2 minus T1. Okay, now I am taking T3 as a common from this, T5 from the common from this, and T2 from this. Okay, sorry, T1. So I have Cp T3 common, 1 minus T4 by T3 plus Cp into T5 into 1 minus T6 by T5 minus Cp T2 by T1 minus 1, and T1 is common. So T4 by T3, now look at this. T4 and T3 are on the isentropic line. So T4 T3 isentropic expansion. So I can write the pressure ratio like T2 by T1. I have one relation from for isentropic process. T2 by T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma. Okay. So T3 by T4 I can write like this. Sorry, T4 by T3, because in our question T4 by T3 is there. So T4 by T3 is what? P4 by P3 raised to gamma minus 1 upon gamma. Okay, so what is P4? P4 is the intermediate pressure, and P3 is the maximum temperature, maximum pressure, that is R times P1, and gamma minus 1 upon gamma this. So this we will use this term in the next following step very much. So it will be very hectic to write every time gamma minus 1 upon gamma. So I'm giving the name as B, capital B. Okay, so pi by R times Pi power B. So Pi is what? Under root R into P1. So it will be 1 upon under root R power B. And similarly T6 by T5, because in previous equation we have T6 by T5 ratio, that is P6 by P5 power gamma minus 1 upon gamma. Sorry, again I'm writing here, so I'm writing B, because B is we have taken as gamma minus 1 upon gamma. If you put P6 is the what? Intermediate pressure, sorry, initial pressure, and this is intermediate pressure. Okay, P5 power B. So when you put this, you will get 1 upon under root R power B. Okay, because why? Because we have this relation pi is equal to p1 into under root r. So this, if you put the value here, p1 will get cancelled, so 1 upon r. Similarly, t2 by t1 is equal to p2 by p1 raised to gamma minus 1 upon gamma, or p2 is what? R times p1, so it is simply r times b. Now we have three values, and we will put this value in this equation, w net work done equation. So let us put, so net work done now this case is cp t3, and t4 by t3 is what? uh, that is 1 minus 1 upon r power b by 2. I can write like this, okay, because whole power raised to b and this is on square root, so r power b by 2 plus cp t5 common into 1 minus 1 upon r power b by 2 and minus cp t2 into r power x minus, sorry, r power b not x. This is the effect of maths, where that every time we are writing x minus 1. Okay, so cp t2, and sorry for the bad handwriting because there is some issues here in writing. So, and t3 and t5 are the same as I already told you. So t3 t5, I can write this term as a 2 times cp t3 into 1 minus 1 upon r raised to b by 2 minus cp t2 r power b minus 1. Okay, so this is the w net. For maximum net work done, so this t3 and t2 are the, sorry, t3 not here, t2 here, t1 we have here, t1 we have taken t1 common in the previous slide. Okay, here you can see, here we have taken t1 as a common. Okay, t1. So now T3 is the upper limit that is fixed by the metallurgical condition. T1 is the atmospheric condition that is also fixed, and here it is taken as a perfect gas. So Cp is also constant. 2 is as a constant. So only variable, and the gamma B. What is B? Gamma minus 1 upon gamma. And as this is the perfect gas, so gamma value will also remain constant. So B is also constant. So only variable is R. So for that maximum value, we have to differentiate this net work done with respect to R. So we will get 2Cp into T3 as a constant, one differentiation will become 0, minus R power B by 2 minus B by 2, and this minus minus plus B by 2 will come here, and there is one less, minus Cp T1 is become constant, and here R power B, that is B, and R power B minus 1. Okay, so this is the, and equate it to 0. So we will have a value of Cp T3 into 2 times Cp T3 into B by 2 minus of B by 2, sorry, minus minus plus, because this minus B by 2 and this minus B by 2 will get cancel out, and we will have 1 upon R power B by 2 plus 1 is equal to, because there is a negative term, compression work, so it will go on the right side, so it will become positive, Cp T1 into B times R power B minus 1. Okay, so B will get cancel out, 2 will get cancel out, Cp will get cancel out. So we have the ratio here T3 by T1 is equal to R power B minus 1 plus B by 2 plus 1. So because the multiplication of the same base, so the power will be in addition. Okay, so b plus b by 2, that is R power 3b by 2. Okay, so when this power goes on the left side, so we have R is equal to T3 by T1 into, sorry, this power, not into, this power 2 by 3 b. Now what is the b? We have to put the value of b, so we will get R is equal to T3 by T1 into, sorry, raised to 2 by 3 times gamma minus 1 upon gamma. Okay, so this is our final derivation, and this question has been asked for 20 marks. So this is the derivation. If you have any doubt, then ask again. I will derive again in the next video. Okay, so for this kind of questions daily, so subscribe my channel and and press that bell icon so that you will get the notification when I upload the new video. And till then, tomorrow we will meet with some new video. So till then, keep studying, stay focused, and be safe.